Hey everyone, so today we're going to go over how to solve problems that involve Parabolas Focus and Directrix. And what we want to keep in mind is a few things. We want to keep in mind that the focus point is always within or hugged by the parabola. So if it's facing up, the focus point is above the vertex point. If it's facing down, the focus point is beneath the vertex point. And the directrix is always some line that lies outside the parabola. So it could be here, it could be vertically, it could be up here, any direction, as long as it's not inside of it. And we also want to keep in mind this key fact that the vertex point is the midpoint between the focus point and some point on the directrix. So if you were to draw the axis of symmetry of the parabola, you would see that they all line up along that line. So this point on the directrix is the point that you're focusing on. And when you have all three of these together, it can help you easily make the equation and find other features of it. So let's look at the August 2017 Regents question 6. It says, which equation represents a parabola with the focus at 0, -1, and the directrix y equals 1? Now, the formula that you want to use to help you create the equation is the conics form, or what I call the focal length form. So that's x minus h squared equals 4p y minus k. And the pieces of the equation that you're looking for are the h, k, and p, right? And that's why I call it the focal length, because the p represents your focal length between the vertex point and the focus point, this distance right here. So let's start off by writing out what they gave us. They gave us the focus point, so I'm going to write FP for focus point, 0, -1. We know that the vertex point is the midpoint in between the directrix and focus point, so I'm going to put VP for vertex point, and we don't know what that is. And they told us that the directrix is the horizontal line y equals 1. So whatever the y values are, it'll always be 1. So since we know that the point that we're looking for on the directrix lies along the same line of axis of symmetry as the vertex point and the focus point, they're all going to have the same x value. So since the focus point's x value is 0, that means the vertex point's x value is 0, and the directrix x point is 0 as well. And from this equation, we know the y-coordinate of the directrix is 1. So then we just need to figure out, well, what's the midpoint between the focus point and the directrix? Well, we can say 1 plus -1 divided by 2, well, that's going to give us 0. So our focus point is 0, 0. Then, to get the focal length, that p value, you want to look at the distance between the vertex point and the focus point. How do you get from the vertex point to the focus point? Well, that's -1. And now we have our values. For them from the vertex point, we can get our h, k, and now we have our p. So I'm going to rewrite the conic form, or the focal length form, of the quadratic equation. And then I'm just going to substitute all the values that I've obtained from doing this exercise. So we're going to get x minus 0 squared equals 4, and our p is -1, y minus 0. Then we just start distributing and simplifying, so this just becomes x squared equals -4, and this becomes y. And our answer choices are in the x squared equals whatever value form, so our answer ends up being choice 2. And that's pretty much it. Some of you may be asking, well, why should we go from the vertex point to the focus point? Why can't we go backwards? Well, that's totally fine. You just have to keep in mind that you're taking since you're going in the opposite direction, you're using the opposite sign. So this won't just be p equals, this is going to be -p equals. So from 0 to 1, it's 1. So you have -p equals 1. If you rearrange that equation, that's going to be p equals -1, which is exactly what we got here. So it's best to just focus on the distance between the vertex point and the focus point. You'll always get the positive p value, whether it is actually negative or not. So let's take a look at the June 2017 Algebra 2 Regions, question 17. A parabola has its focus at 1, 2, and its directrix at y equals -2. The equation of this parabola could be, and then you have all these choices. So you want to start with the same setup as we did last time. We have focus point, vertex point, and directrix. Our focus point is 1, 2, so that means the x-coordinates for the others are going to be 1 as well. Our equation for the directrix is y equals -2, so we're going to leave that there. Now we want to find the midpoint of the focus point and the directrix. That's going to be -2 plus 2, that's 0, divided by 2, that's 0. Let's find our focal length to get from 0 to 2. Focal length is just 2. And now we have everything we need to plug into the conics form of the equation. So that's x minus h squared equals 4p y minus k. When we substitute, I'm going to make some space here. When we substitute, we're going to get x minus h is 1 squared equals 4 times 2 y minus 0. We're going to simplify that. Our value, our choices are in y equals form, so we have to get y by itself. So we're going to have x minus 1 squared equals 8y. Let's multiply both sides by 1/8. These cancel out here. We're going to get 1/8 x minus 1 squared equals y. And that's going to end up being choice 4. And that's pretty much it when we're going about solving these problems. For those of you that may be asking, well, how do I know that it's only the x values that are being consistent, but not the but when would I know that the y values are consistent? Well, let's take into account the equation for our directrix, right? Our general parabola could be facing up and down. Oh, but it could also be facing left and right. So if our focus point is here and our vertex point is here and our directrix is somewhere down here, their axis of symmetry is an x equals equation, some number, right? So that means the x values don't change. But if it was parabola facing sideways somehow, then our axis of symmetry is some y equals equation. The focus point is here, the vertex point is here, and then the directrix is somewhere out here. So because our axis of symmetry is a y equals equation, we're going to be taking the y values, but the x's is going to change. So it's only in this situation where the y values stay consistent and the x values change. In this situation, which is commonly seen on the regions, at least on the common core regions, the x values are going to stay the same, but the y values change. So this situation is very common. But if you are in this situation, then you just need to recognize that if the equation of the directrix is some x equals number, then your y's are going to be the one that stays the same. And that's pretty much it. If you have any questions, leave them in the comment section below, like and subscribe, and I'll make more videos later. Bye!